This video is on graphing quadratic functions by Dr. Archie Earl. Quadratic functions are functions of the form f of x equals ax squared plus bx plus c. F of x equals ax squared plus bx plus c. And of course, you have to have this quadratic term in there for it to be quadratic. You have to have the x squared term. If you don't have the x squared term, then of course it's not quadratic. Now, quadratic functions, when you graph them, they always look like this or this. It looks like a U or an upside down U. That's how the quadratic function looks. Now, this point here is called the vertex of the quadratic function. It's the highest point or the lowest point of the function. That's the vertex. And the vertex has an x-coordinate and a y-coordinate. The formula for the x-coordinate of the vertex is x equals b over 2a. Now, if you look at this quadratic function, you can see where the a and the b come from. The b is the number beside x, and that's in this part of the formula, the numerator of the formula. That's where the b goes. And the a is the number beside x squared. So whatever those numbers are, all you have to do is substitute them into this formula, and that will give you the x-coordinate of the vertex. Now, after you get the x-coordinate of the vertex, you have to substitute that into the quadratic function to find the y-coordinate of the vertex. These are the steps that are involved in graphing a quadratic function. I'm going to back off here so that you can see all of those steps. If you need to, you can stop the video and write down those steps. All right, let's look at the steps. All right, step number one. The first thing you have to do is find the x value of the vertex. And to do that, you use this formula. X equals negative b over 2a. After you find that vertex, you have to substitute that into the equation to find the y-coordinate of the vertex. And then you just graph the vertex. You graph the vertex in the xy plane. And after you graph the vertex, you find 2 points on the left side of the vertex. And then, step 3, you duplicate the points on the right side of the vertex and draw the graph. Once again, those are the steps. Now, let's look at an example so that we can see exactly how those steps work. Suppose we want to graph this quadratic function. Suppose we want to graph f of x equals negative 2x squared plus 3x plus 4. Now, the first thing we have to do is find the x-coordinate of the vertex. To find that, we have to identify a and b. And we said that a is a number beside x squared. So you can see here the number beside x squared is negative 2. So that means a should be negative 2. B is the number beside x. The number beside x here is 3, so b should be equal to 3. And that's what we have here. Also, please notice, f of x means the exact same thing as y. So instead of writing this equation as f of x equals negative 2x squared plus 3x plus 4, we can just write it as y equals negative 2x squared plus 3x plus 4. And that's what we have done here. we've written the equation as y equals negative 2x squared plus 3x plus 4 because y is the exact same thing as f of x. And now we can identify a and b. Once again, a is negative 2, the number beside x squared. B is positive 3, the number beside x. So now we can substitute those into the formula for the x-coordinate of the vertex. We get x equals negative b over 2a. That gives us negative 3 over 2 times negative 2. There's nothing we can cancel there, so we just multiply 2 times negative 2, we get negative 4. We get negative 3 over negative 4. A negative divided by a negative, of course, would give us a what? If you said a positive, you're right. So we get a positive 3/4. Now, we want to graph this. Graphing is easier if you round your numbers off to decimals. So 3/4 is 0.75. We round that off to a decimal, it'll be 0.8. So that's what we can use for graphing, 0.8. But to find y, we have to substitute the 3/4 into the equation to find the y-coordinate of the vertex. This is the x-coordinate of the vertex. So now we take the 3/4 and we substitute that into the equation for x. So once again, the equation is y equals negative 2x squared plus 3x plus 4. And we substitute the 3/4 in there for x. We're going to have negative 2 times 3/4 squared, and that's what we have here, plus 3 times 3/4 plus 4. And we simplify that further. 3/4 squared is 9/4, and 3 is the same as 3 over 1. So we can multiply 3 times 3 and get 9, and 1 times 4 and get 4. So in the next step, we get negative 2 times 9 over 4 plus 9/4 plus 4. Then we have to find the LCD. 4 is the same as 4 over 1. We can multiply the negative 2 times the 9. That would give us 18 over 4. So in our next step, we get negative 18 over 4 plus 9/4 plus 4 over 1. The LCD is 4. Multiply the top and bottom here by 4 to get the LCD. This is going to be 16 over 4. So we get negative 18 over 4 plus 9 over 4 plus 16 over 4, and that will give us 7 over 4, which as a decimal would be 1.7. So the 1.7 is the x-coordinate of the vertex. So now we can write the vertex. The vertex would be 0.8, comma 1.7. That's the vertex, 0.8, comma 1.7. That's what we're using to graph the vertex, because once again, it's easier to graph if you round them off to decimals. So now we graph that vertex. So we draw the xy axis and we graph the vertex. Once again, the vertex is 0.8, 1.7. So that means that we go 0.8 to the right. So we have to estimate where that is. This is 1. So 0.8 is before you get to 1. So 0.8 would be here. And then we go up 1.7, which would be here. So that point there is the vertex of our parabola. So now we need to find 2 points on the left. We can find any 2 points, and it's up to you what points you choose. But I've chosen, this is my vertex. So on the left side of my vertex, I've chosen to use x equals 1 and x equals negative 1 and x equals negative 2. I've chosen to use those 2 points on the left. Somebody else might choose to use x equals 0 and x equals negative 3. It's totally up to you. The final graph will be the same regardless to what 2 points you use. Now, once you choose these 2 points for x, you have to substitute these two numbers into the equation to find y. And the best way to do that is make a little table like I've done here. In order to find my 2 points on the left, I chose x equals -1, x equals -2. I substitute -1 into the equation for x. The equation is y equals -2 x squared plus 3x plus 4. I substitute -1 for x. I get -2 times -1 squared plus 3 times -1 plus 4. I square -1, I get 1. 1 times -2 will give me -2. 3 times -1 is -3. And then I add everything together, and I get -1. So my first point here will be -1, -1. For my second point on the left, I use -2. I substitute -2 into the equation to find y. I substitute -2 for x. I get -2 times -2 squared plus 3 times -2 plus 4. I simplify that using arithmetic, and that gives me -10. That gives me -10. So my second point on the left is -2, -10. So now all I have to do is graph those 2 points on the left. The first one is -1, -1. So I go 1 to the left, and then I go down 1. Oh, I went down too far. I go 1 to the left and then down 1. You see, -1, you go in the x direction first. So you go 1 to the left because it's negative. And then y is -1. So that means you go down. If y was a +1, you would go up. So that gives me that point there. My next point is -2, -10. So this time I go 2 to the left. You see, that's my second point there, -2, -10. So this time I go 2 to the left and then down 10. So I go 1, 2 to the left and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I had to add on some marks there. So this would be my